Good morning, students. In the last class, we discussed about the reaction mechanisms, means the detailed explanation of the bond cleavage, atoms formation, intermediates formation, and also product formation and the effects involved in the mechanism. So, in that we explained the bond cleavage. Okay. So, next we have to explain that intermediates. And again, I'll go with the bond cleavage only. Okay. So, listen, students. The first one is the bond cleavage or fission of bond. Okay. So as I told you in bond cleavage, two types is there. One is homolytic bond cleavage. Homolytic bond cleavage. Homo means what? Same. Lytic means breaking. The breaking of the bond takes place which results in the formation of same type of atoms. Okay. So I'll take the example as we are going to study about the which compounds, organic compounds only means I'll take the example of organic compound. So listen, one of the best example is CH3, CH3. Okay, next CH3, Cl. Assume homolytic bond cleavage is going to take place. So students here, homolytic bond cleavage takes place means listen, this is carbon is bonded to carbon. Correct? CH3 is there, single bond CH3. How can we write? Carbon, carbon like 3 hydrogen atom. So this bond represents what? The bond between carbon and carbon is a single bond. Then, how this bond will form? So one electron of this carbon combined shared between another electron of another carbon and they form a bond. Understand? So at this time, this carbon and this carbon, their physical properties, their chemical properties, their electronegativity, periodic properties, the ionization energy, everything remains same. Understand? Because here also it is CH3, here also it is CH3. Both are carbon atoms, their bonded atoms, everything is remain same. Their physical, chemical and periodic properties also same. So, in the bond cleavage, the main concept is electronegativity. Understand? So in the bond cleavage, the main concept is electronegativity. So students here, what happens if the bond cleavage takes place? Remember always the bond breakage takes place at the center of the bond. So this is the bond cleavage, breaking of the bond. Then what happens? This electron stay with this atom, this electron stay with this atom. Then they form CH3 dot plus CH3 dot. Okay. Next, second one is Cl2 ute. Cl single bond Cl. Okay. So if it is like this, how the bond will form? Due to so one electron of this chlorine shared between covalent bond is what? The bond formed by the sharing of electron. That is covalent bond. It is not transferred. It is just shared. But in NaCl, what happened? The electron of Na is completely transferred to Cl. That's why it is Na plus. That's why it is Cl minus. Understand? Here transfer of electron takes place, so it is ionic bond. Here only sharing takes place, that's why it is covalent bond. Okay? So Cl dot, then if we do the bond cleavage, we will get Cl dot and Cl dot. Okay? So students, from this we can easily say what is homolytic cleavage means. If the bond breakage takes place, then they form same type of atoms are intermediates. They are not stable. After breaking of the bond, they won't become stable. This is free radical. This is free radical. This electron tells about what? Free radical. Okay. So after homolytic cleavage, we get free radical. Not only in this, in any way, if you do homolytic cleavage, you will get free radical only. Okay, so this is homolytic cleavage. Second type is what? Heterolytic cleavage. This is very, very important. Heterolytic cleavage. So listen, hetero means what? Different. Lytic means breaking. After breaking of the bond, okay, after this is cleavage means breaking. Heterolytic means different atoms. Okay, so after the breaking of the bond, we will get different atoms. Okay, here both the atoms are free radical only. They are same. That's why it is homolytic. But here it is heterolytic. Hetero means what? Different. After the cleavage of the bond, they form different atoms. I'll take an example of this CH3Cl. Okay, as I told you, in the cleavage of the bond, electronegativity plays a very important role. So among this carbon and this chlorine, which one is highly electronegative means this one is highly electronegative. Actually, this bond is formed by the sharing of electron. Okay, so after the bond formation, when we observe, we will get the electron of, this is the electron of chlorine. So electron of carbon here. So in the spectra, we can observe, means in any spectroscopy, spectrum means microscope, like that. For observing this type of compound, we use a special type of device called as spectra. So when we observe the spectrum, then the electron of carbon seems to be near chlorine. Why? Because in the periodic property I told you, so along the period, electronegativity increases. Electronegativity means what? The capacity of an atom to attract shared pair of electron towards itself. The capacity of atom to attract shared pair of electron towards itself. That is called what? Electronegativity. So among carbon and chlorine, so halogen, carbon is 14th group, halogen is 17th group. So this is highly electronegative. So the electron of carbon, it seems to be near this Cl atom. Then, if the bond cleavage takes place, okay, so then what happens? Listen students here, CH3 is there. The electron of CH3, so listen here, CH3, 3 bonded atoms are there. One electron is with that, so there is no charge, it is a free radical. Here, 3 atoms are there, but there is no electron. If there is no electron, then it is positive in charge. Okay, next, so this one, Cl atom is there. This is the electron of Cl atom, Cl dot, but here extra one electron is there. Then it will get minus charge. Understand? So here this is CH3 plus, this is Cl minus. So this is what? Carbocation. Cation means positive ion. So this carbon is with a positive charge, hence it is a carbocation. Okay, so take another one example for this same heterolytic cleavage. Okay, so in this heterolytic cleavage, take CH3 bond Li. Okay, CH3 bond Li. Or take initially we have Li bond CH. Both are same, just take like this. Okay, so students here, this is the first group element, lithium. This is the 14th group element, carbon. So compare to this and this. So this is metal, this is non-metal. Which one is highly electronegative means non-metals are highly electronegative. These are highly electropositive. You know that always the metals are with a positive charge. Metals ke avaglo negative charge irolla. So this one is getting plus, this one is getting minus. So listen, so the electron of this and electron of this, okay, there is no sharing of electron takes place. Here completely transfer of electron takes place. Why? Because this is lithium. It is stable in Li plus state. So complete transfer of electron takes place. Are you getting? So here complete transfer of electron takes place. Or otherwise I will take the example of, instead of lithium, you take CH3B. B means boron. We have to balance the valency, but just to remember, it is like B. Understand? So here CH3 is there, B is there, boron. Actually boron is trivalent. We have to write like this. Okay, for explanation, I am writing only CH3B, explaining only one bond. It will be like CH3, 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 then it is satisfied. Understood? Okay. So listen, for explanation, I will take only this. Okay. So students, here boron is there, here carbon is there. Okay. So then what happens? If it is an electrophile, positively charged species, compared to this and this is highly electronegative. So here these two gets bonded by the sharing of these electrons. So then what happens? This is CH3 bond B. Then as compared to boron, carbon is highly electronegative means it seems to be the electron of boron is nearer to carbon because this is highly electronegative. But here Cl is highly electronegative. That's why. So here the electron is nearer to chlorine. But here it is carbon is highly electronegative. That's why boron electron it seems to be near that carbon atom. Then if we break the bond, cleavage of bond takes place, then it is forming CH3 with the extra electron means minus plus B plus. This is the product. So I write the product here. CH3 minus plus B plus. So students, this one is carbon ion. Anion means negative charge. Cation means positive charge. Carbon ion means carbon with negative charge. Carbocation means carbon with a positive charge. This one is free radical. Carbon free radical. We get free radical. Understand? So students, as I told you, the first thing is bond cleavage. Second thing is what? Intermediates. Intermediates in the reaction mechanism. Okay. What are those intermediates? One is free radical, one is carbocation, another one is carbon ion. Understand? So now we are going to discuss about what is carbocation, what is its stability, what is carbon ion, what is its stability, and what is carbon free radical, and what is its stability. Okay? So we'll go one by one, starting from the free radical. So here Okay, listen. So the in second one is what? Intermediates. I take here. Second one is intermediates. So in this, the first one is carbon free radical. Or you simply take free radical. Carbon free radical or free radical. So students, what is the statement? So listen, a neutral molecule, with unpaired unpaired electron is called as free radical. So students, this is example for only, sorry, this is the definition for only free radical. But in the reaction mechanism, we are going to get carbon free radical. Means there is neutral atom, neutral molecule must be a carbon. Okay, a neutral carbon molecule with unpaired electron is called as carbon free radical. This is the definition for only free radical. Okay, so students, so this and write this these free radicals formed by homolytic cleavage. These radicals, free radicals, formed by homolytic cleavage. So this is the definition. This is the reason why the free radicals will form. So students, in this free radical, three types is there. One is alkyl, primary, secondary, tertiary. So listen, what is alkyl, what is primary, what is secondary, what is tertiary? So next one is stability order. Stability order of free radical. Okay? So listen here. Okay, so students, if one carbon is there, okay, so it is bonded to 3 hydrogen with the 1 electron pair. In neutral molecule, there is no plus charge, there is no minus charge, but 1 unpaired electron is there. This electron is not paired, it is free. That's why it is called as free radical. It is not bonded with anything. So next, to this compound, CH3 is there. So I'll take example here. CH4. Okay, so 1 hydrogen C H H H H. Simple molecule it is. If this H is not bonded, then it is with the 1 electron. Then it is what? CH3 dot. Next, if 1 hydrogen is replaced by any carbon. If 1 hydrogen, this radical is bonded to another carbon like CH2, CH3 you take. Are you getting? CH2, CH3. So here near CH2, free radical is there. So the carbon where the unpaired electron is there, that is again bonded to the 1 carbon. Okay, next another hydrogen is replaced by CH3. Then what is the structure here? This CH, free radical, it is further bonded to 2 carbon. So here 1 carbon, here another carbon. Okay, so students, this again replaced by CH3. Then this is how the carbon which is further bonded to the carbon. Okay, so listen. So by this, you know how we can get these radicals by the replacement of the one hydrogen with the respective carbon atoms. So listen, students. If alone only one carbon atom is there, no other carbon atoms are there, then it is said to be alkyl. Then it is said to be what? Alkyl. So listen next. CH2 single bond CH3. If the free radical carbon with the free radical is bonded to further one carbon atom, the carbon with the free radical, if it is bonded to only one carbon atom, then it is primary alkyl. Primary alkyl. Okay, so listen. If one carbon atom where the free radical is there, if it is bonded to further two carbon atom, the same carbon which is having the free radical, which should be bonded to what? Two carbon atom, then it is secondary alkyl. Secondary alkyl. So listen, if the one carbon with unshared electron, if it is bonded to three carbon atom further, then it is tertiary alkyl. Okay, so students remember here 1, 2, 3, 4 is there, tertiary it is. So if it is 1, 2, 3, 4 carbon atom with this 3 atoms means it must be CH2, you can write it as CH2, 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 CH3 also with this dot. So the formula of these two is same. 1, 2, 3, 4 carbon atom. 3 plus 3 plus 3, 9 hydrogen atom. With the one free radical. Here also 1, 2, 3, 4 carbon atom. So 2 plus 2 plus 2, 6 plus 3, 9 hydrogen atom with the one free radical. The molecular formula is same. But here it is primary. Why? So here the one carbon atom where this free radical is there, it is further bonded to only one carbon. This bond is this carbon is bonded to only one carbon. Understand? Then that must be a primary. No, we don't bother about this remaining parent chain. We don't bother about the length of the chain. We have to consider only this carbon atom. If it is bonded to only one carbon, then it is primary. 2 carbon, secondary. 3 carbon, then it is tertiary. Okay, so here listen. So this hydrogen is the carbon is there. So this carbon, assume like this CH3. So it is bonded to 1, 2, 3 carbon atom. It may be tertiary. So sorry, secondary. So this one is that is tertiary. This one is neo. Are you getting my point? So if one carbon atom is bonded to one carbon, the carbon which is bonded to one carbon, primary. The carbon bonded to two carbon, that is secondary. Here, the carbon bonded to three carbon, then this is tertiary. If the carbon bonded to 1, 2, 3, 4 carbon, then it is neo. So if you want to understand, I'll write here. So carbon bonded to carbon, primary. Okay, carbon bonded to two carbon, then it is secondary. This carbon bonded to three carbon, then it is tertiary. If the carbon bonded to four carbon, then it is neo. Remember this, it is same for all carbocation, carbon ion, carbon free radical and alkyl halides, aryl halides, whatever you may be, if it is primary, secondary and tertiary, the rule follows the same. Are you getting? Primary, secondary, tertiary. Okay. So next, now we are going to discuss about the stability of the molecules. What is that stability? So students listen, in the free radical, the CH3 is there, here only one bond is there, it is less stable. Are you getting? For the breaking of the bond, it is less stable. Are you getting? So listen. So the stability order is in this manner. Okay, so tertiary is greater than secondary, greater than primary, greater than alkyl. This is what stability order of the free radical. Tertiary alkyl free radical urine. This one is also free radical. This one is also free radical. This one is also free radical. Okay, so the stability order is tertiary greater than secondary, greater than primary, greater than alkyl. What is the reason for that? Why the tertiary alkyl halide is more stable than this alkyl, than secondary, than primary, and then alkyl? What is the reason for that? The reason for this is the 3CH3 groups. Those are all bulkier groups. Understand? For the further reaction, so these won't make this carbon atom to react easily. By the resonance, they made this free radical very stable. So this is explained by the effects. Later I told you, inductive effect is there, electromagnetic is there, resonance is there, hyperconjugation is there. After the formation of the free radical, those effects also exhibit in the reaction mechanism. The cleavage of the bond takes place, intermediate formation takes place. Later what happens? After the formation of the intermediates, special effects are observed in the reaction mechanism. What are those? Inductive, electromagnetic, resonance, and also hyperconjugation. Okay. So due to this tertiary carbon atom is there. Why it is more stable means due to the what I told the remaining effects. So here the effect involved is hyperconjugation. So these involved in resonance. So if they involved in resonance means they become highly stable. Are you getting? So later while explaining the hyperconjugation, again I will say, just remember due to the presence of the 3CH3 groups, so this one become highly stable. If the CH3 group decreases, then what happens? The stability of the free radical decreases. Understand? This is what carbon free radical, one type of intermediate. So the next we will discuss about carbocation, the second type of intermediate. So remember students, here if you want to say the carbon with the what are understand? Carbon with the 7 electron system. That is called as carbon free radical. It is different for different atoms. Carbon के मात्रा 7 electron system इधर free radical आगे रहता है. Carbon ना बिट्टू नहीं वेलंती भी nitrogen ना तो मन रहते तिलकोड़. ये lone pair electron से रहता है. ये free radical आगे तो नहीं ना रहता है. इधर bond आगे रहता है. So ये ಎಷ್ಟು electron होते हैं? 2, 4, 6, 7 आता है. Okay, nitrogen में बदल रहती है. Oxygen. So atoms with the 7 electrons are said to be what? Free radicals. Okay? 7 electron system is free radicals. Listen, carbocation means one definition, the carbon with positive charge. Carbon with positive charge or having 6 electron system. Having 6 electron system is called as carbocation. Carbocation. Listen, I give here. This is a hydrogen, hydrogen, hydrogen. Here two molecules are there. Okay, it's carbon with the plus charge. So I take here H, here you take Cl. So here two electrons are there, right? So this electron completely transferred towards it, shared towards this Cl, or move towards this Cl. Then after one breakage is H with a plus charge plus Cl minus. Then count the number of electrons through 4, 6. It is having 6 electron system. Correct? So that's why this is what? The carbon with a positive charge are having the 6 electron system is called as carbocation. Okay. Now, when this carbocation will form, these carbocation formed by which type of cleavage? Heterolytic. Heterolytic cleavage. Understand? So students, the stability of order of the carbocation also follows same. The stability order of carbocation is also tertiary carbocation greater than secondary, greater than primary, and greater than alkyl. Carbocation I am telling. Okay. So listen here. This primary, secondary, and tertiary remain the same here. Okay. So listen, alkyl means this only with only one carbon. Primary means carbon with another carbon. Secondary means carbon with another 2 carbon. Tertiary means carbon with another 3 carbon. But here only thing changes. See, instead of free radical, it becomes carbocation. Carbocation. So students, now here this can be written as alkyl cation, alkyl carbocation. This one is primary alkyl carbocation. Next, secondary alkyl carbocation. Next, tertiary alkyl carbocation. So what is this primary, secondary and tertiary? I told you, always this is with respect to what? This is written with respect to carbon atom. Primary, secondary and tertiary, it won't changes. Only the changes is what? Free radical, carbon ion and carbocation. Understood? So this is about carbocation. Carbocation means it is a carbon with a positive charge and having 6 electron system is called as carbocation. Remember students, another one thing I learned, right? So these carbocations formed by heterolytic cleavage. But when, so in heterolytic cleavage there is also a formation of what is that? Carbon ion also, means with a minus charge. When the positive charge will form? When this must be a highly electronegative. So, these carbocation formed by the heterolytic cleavage of bond when carbon is bonded to electron withdrawing group. Electron withdrawing group, nothing but nucleophile. Later I will explain what is nucleophile. Just remember electron withdrawing group. Don't write nucleophile, just take electron withdrawing. Okay? So listen, electron withdraw. Withdraw means remove. Withdraw means tegiyor. From where? From carbon. It withdraws this electron from the carbon towards itself. When the homolytic cleavage takes place, heterolytic cleavage takes place, the bond when the carbon is bonded to the electron withdrawing group, then that must be, means the carbon is bonded to the highly electronegative atom. Then only they form carbocation. If it is electron positive, then it form. If electron releasing group, then it form what? Carbon ion. Are you getting? And it is electron donating group, releasing group, then it is forming what? Carbon ion minus charge. I told you before. Okay, so this is all about carbocation. So the next one intermediate is carbon ion. So the next one is carbon. So only the change here, students. The carbon with the positive charge changes to what? Negative charge. The carbon with the negative charge are having 6 electron changes to what? 8 electron. Okay, the carbon with the negative charge are having the 8 electron system is called as carbon ion. Only this is the change. How? Listen it. So your carbon is there. Here they are bonded like this. So if any electrophile or electron releasing group is there, we don't know which group it is. It releases electron. So if electron releasing group is there, this carbon becomes highly electronegative compared to this. Then this electron move towards this carbon. So after the breaking of the bond, so this bond seems to be here H, and here the electrons are here. And this is electron releasing group. So if the bond cleavage takes place, how many electrons here? 2, 4, 6, 8. Correct? Here 2, 4, 6 and 8. So when the carbon ion will form, then this form of what? CH3 minus. That means extra carbon is here. Sorry, extra electron is here that constitute 8 electron system. Understand? So the carbon with the negative charge are having an 8 electron system is called as carbon ion. So students, this carbon ion, this is also a electrolytic cleavage. This one become plus, this one become minus. So when this become minus, when it is bonded to electron releasing group. So here, first point, these carbon ions are formed by heterolytic cleavage of bond when carbon is bonded to which group? Electron releasing group. Electron releasing group. So students, in the next class I will explain which are electron releasing groups, which are electron accepting, withdrawing groups. Understood? Okay. So just remember electron releasing and the electron withdrawing group. Another, if we consider stability order of carbon ions. Okay, so students, it is just reverse of the free radical. Means this is primary is greater. Sorry. This one is alkyl is greater than primary, greater than secondary, greater than tertiary. Stability is just reversed. In free radical and in carbocation, it is tertiary greater than secondary greater than primary. But in the carbon ion, it is just reverse. It means this one is highly stable. Understand? So This is minus, minus, minus. Remember, always plus and minus written in a circle. That is the rule. So next, listen. This is greater. The symbol follows like this. So instead of this, students, you just replace both are primary, secondary, and tertiary only. Only the changes here. Carbon ion. This is a primary carbon ion. This is secondary carbon ion. This is tertiary carbon ion. Understand? So this is all about the intermediates formed in the reaction mechanism due to the cleavage of one. If the homolytic cleavage, free radical. Order is free radical means what? A neutral molecule with the unshared electron or with the 7 electron system. So listen, and step by step I will say, if it is 6 positive charge, then it is carbocation, it is 6 electron system. If it is free radical, so unshared electron is there is no charge, it is a neutral molecule, but 7 electron system. Carbon ion is there, so minus charge, okay, it is 8 electron system. So stability for carbocation, tertiary greater than, secondary greater than, primary greater than, alpha. For free radical, tertiary greater than, secondary greater than, primary greater than, what is it, alkyl. For this carbon ion, alkyl is less than, sorry, alkyl is greater than primary, greater than secondary, greater than tertiary. This is the stability. So I write all the chart for intermediates, then it seems easy to you people. Write down the chart. Here it is. Carbocation, carbon, free radical. Next, carbon ion. Okay, so in that, first one is, okay, charge. First one is charge. Positive charge. Remember, always you should consider carbon charge it is. The charge of carbon atom, positive charge. Free radical means neutral charge, and this is negative charge. Okay, next, second one, electron system. Electron system. This is 6 electron, this is 7 electron, this is 8 electron. Okay, next, third one, stability. This is tertiary greater than, secondary greater than, primary. This is enough. Okay, this is tertiary greater than, secondary greater than, primary. So this one is primary is greater than, secondary greater than, tertiary. So listen, alkyl after primary always alkyl will come. Okay, next another one, cause of formation. Okay, so this will caused by heterolytic cleavage when bonded to, so listen, EWG, that means electron withdrawing group. Heterolytic cleavage when bonded to electron withdrawing group. So this one is homolytic cleavage, and this one heterolytic cleavage when bonded to which group? Electron releasing ERG means electron release. So this is about the intermediates formed in the reaction mechanism. Understood? Okay. So in the tomorrow's class we will discuss about electron displacement and what are these electron withdrawing group, what are those electron releasing group, what are nucleophiles and what are electrophiles. Okay. Thank you.